first what you can do, first you read about all the units and make a note on the important points, and then look into the question and answers, and then prepare for that. Okay, right. So this is heterocyclic chemistry. So in this introduction part, nomenclature part, so nomenclature of simple and fused heterocyclic compounds. So we are also discussing about the synthesis and reactions, more particularly the synthesis of pyrazole, synthesis of imidazole, reactions of pyrazole, reactions of imidazole, and pyrazole means two nitrogen containing, more particularly 1 and 2 position of the nitrogen in a 5-membered ring. So 1 and 3 position of nitrogen in a imidazole ring. So that means pyrazole and imidazole are the 5-membered ring. So there will be a nitrogen at 1 and 2 position in pyrazole, 1 and 3 position of nitrogen in imidazole. And oxazole means what is called as oxa means aza. Oxa means oxygen, aza means nitrogen. Oxygen and nitrogen, if these are at 1 and 3 position in a 5-membered ring, is called oxazole, and 1 and 2 position, oxygen and nitrogen, if at all they are present in a 5-membered ring at 1 and 2 position, is called isoxazole. So thiazole means, thia means sulfur, aza means nitrogen. The sulfur and nitrogen containing 5-membered ring is called thiazole. So more particularly, the sulfur and nitrogen at 1 and 3 position in a 5-membered ring is called thiazole. And sulfur and nitrogen at 1 and 2 position in a 5-membered ring is called isothiazole. So from up to this, we are discussing the synthesis as well as the reactions of a 5-membered ring, more particularly azoles. Azoles means a 5-membered ring. And from now onwards, so only the synthesis part we are discussing, synthesis of benzimidazole. So again, benzimidazole means imidazole is fused with benzene. Okay, imidazole is fused with benzene is called benzimidazole. That means in a 5-membered ring, the nitrogens are at 1 and 3 position. So that 5-membered ring, if it is fused with benzene, is called benzimidazole. And we are benz oxazole. What is oxazole? Oxazole is a 5-membered ring with oxygen and nitrogen at 1 and 3 position. If that oxazole is fused with the benzene, then it's called benzoxazole. And then isoxazole, benz-isoxazole. That means what is oxygen and nitrogen at 1 and 2 position in a 5-membered ring, and that is fused with the benzene, and that is called as a benz-isoxazole. So indole and coumarins. So indole, what is indole? Indole is a 5-membered, what is called as a 5-membered ring with the nitrogen, only one nitrogen. Okay, it's called pyrrole. That pyrrole, if it is fused with the benzene, then it's called indole. What it means? Indole is nothing but a pyrrole fused benzene compound. Okay. Then coumarins. Coumarin, I think you are aware about the pyran. So what is pyran? Pyran is a 6-membered ring with oxygen as a heteroatom. So pyran is a 6-membered ring with oxygen as a heteroatom. So that pyran, if it is fused with the what is called as benzene, it's called benzopyra. And more particularly at the second position, if it is a ketone group, so that compound is called coumarin. So what it means? I think a six-membered ring with oxygen is called pyran. A six-membered ring with oxygen and the second position ketonic group is called pyranone, 2-pyranone. This 2-pyranone, if it is fused with benzene, is called coumarins. Okay, so that means in this heterocyclic chemistry, so we are discussing about the synthesis and reactions of azoles, and also we are discussing about the synthesis of benzo-fused compounds. So this is about complete information about heterocyclic chemistry. So now I will go to the next slide. Next slide will give you the information about the structures of few heterocyclic compounds. I will go to the next slide. Okay, so look here, this is pyrazole. Pyrazole means nitrogens are at 1 and 2 position, and this one is imidazole. Nitrogens are at 1 and 3 position. So this is pyrazole, this is imidazole, and this is oxazole. Oxazole means oxygen and nitrogen are at 1 and 3 position, and this is isoxazole. Oxygen and nitrogen are at 1 and 2 position. And thiazole. Thiazole means sulfur and nitrogen are at 1 and 3 position. Isothiazole. So isothiazole means sulfur and nitrogen at 1 and 2 position. And this is benzimidazole. Benzimidazole means you can observe that this is imidazole. This imidazole, if it is fused with benzene, then it's called benzimidazole. And this you know that this is oxazole. If this is fused with benzene, it's called benzoxazole. And what is this? This is isoxazole. If this is fused with benzene, it's called benzisoxazole. And this is the indole. Indole means a five-membered ring with nitrogen is called pyrrole. That pyrrole is fused with benzene is called indole. So this slide will give you the information about the structure of all the compounds. So the compounds which are going to synthesize in this particular heterocyclic chemistry, here it's there. This chart will give you the complete structure of the heterocyclic chemistry of your portions for the first semester. And the next slide, I'm showing about the coumarins. Okay, what is coumarins? So look here, this particular one is called coumarin. So this we are not discussing because this is not mentioned in your syllabus. So that means oxygen and CO group. So this moiety is called pyranone, and the pure benzo-fused pyranone is called coumarin. Coumarin is a name, more particularly trivial name. So with this, what I will do, I will go to the nomenclature. So nomenclature means a few important rules I will recall. Okay. More particularly, what is the suffix, what is the prefix, okay, that part. And also I will take few examples how you can name a heterocyclic compound as per the IUPAC nomenclature. So in this IUPAC nomenclature also, you may get at least 4 marks questions on this IUPAC nomenclature. Okay. So I will go to the next slide. So look here, so what is that? So these compounds are called, you are aware about the prefix and the suffix. Suffix means at the end, prefix means before the name. So if it is a oxygen containing one, compounds are the prefix is oxa. If it is a sulfur containing, the prefix is thia. If it is a nitrogen containing, the prefix is aza. If it is a silicon containing, then it is called sila. If it is a phosphorus, uh, the symbol is P, then it is called phospha. And then if it is a 2 oxygen, it's called dioxa. If it is a 2 or 3 nitrogen, then it's called triaza. If it is 1 sulfur and 1 nitrogen, then it is called thiaza. Thia means sulfur, aza means nitrogen. So with this, I will go to the next slide. So here you can observe that saturated ring and unsaturated ring. So saturated ring means one suffix, and unsaturated means another suffix. And under that, you have to distinguish between the heterocycle containing nitrogen and heterocycle containing other than nitrogen. So no nitrogen means these are the suffixes for unsaturated and saturated. And with nitrogen means these are the suffix for unsaturated. These are the suffix for saturated one. So, but you need to remember these three. So, three-membered ring means saturated means nitrogen containing means it is hints with iridy. Four-membered ring, nitrogen containing, and it is a saturated means ATD. And then five-membered, nitrogen saturated, then it's called OLED. So these three only different, and the remaining thing is parahydro. Okay, so this is okay, remember. And this when it comes to a three-membered ring, nitrogen containing, and if it is unsaturated, then it is called IRE. This is the what is called as suffix. So if it is an oxygen, then it is called oxyre. A three-membered ring, oxygen containing ring is called oxyre. More particularly, double bond containing one. A four-membered with oxygen is called oxyte. And here oxygen containing four-membered ring is called oxytate. So oxytate. And five-membered ring with the nitrogen containing one is called azole. Okay, nitrogen means aza is the prefix, and then OLE is the suffix. Azole is the name. And six-membered ring, the suffix, just by looking into the suffix, INE is the suffix. So nitrogen means aza, sulfur means thia. Okay, and oxygen means oxa. Right. Seven-membered ring, the suffix is epine. And eight-membered ring, ocene. Okay, maybe this here in this semester you are only learning about the 7 and above rings, about only the IUPAC nomenclature. But in your fourth semester you are going to synthesize this particular means you will also learn about the synthesis of higher member heterocyclic compounds. And without nitrogen means it's a small difference. So here the terminal E is not there. Unsaturated RAN, iron, eat. Here one E, this E is not, terminal E is not there. Ethane. So ethane is the saturated one. So whereas in the nitrogen containing and no nitrogen unsaturated, here OLE is the same, but saturated one OLAN, OLAN. And here INE, six-membered ring, here IN. ANA, this is saturated one. So here epine, E is not there, epane. Osin, osane. Onin, onane. Okay, esin, there hekan, and esin, here E is not there. This is this chart you can remember. So if you are remembering this chart, and if you are familiar with the oxygen for oxa, nitrogen for aza, sulfur for thia, then you can write the structure, write the IUPAC nomenclature of the heterocyclic compound. But you should aware about which is substituent, okay, and the order of such substituent. The order of substituent means as per the alphabets, okay. Hydroxy, okay. Deutero means D. If the heterocyclic compound contain hydroxy as well as deutero as the substituent, then D comes first, later hydroxy, and then the parent heterocyclic compound IUPAC nomenclature. So with this, I will take a few examples so that you can. So these are the examples. So this is a saturated oxygen containing. So this is a unsaturated oxygen containing, and this is a what is called as unsaturated nitrogen containing, and this one is saturated nitrogen containing one, and this one is substituted nitrogen containing unsaturated three-membered ring. Four-membered ring is substituent oxo. So this is an oxo substituent, and this is a five-membered ring, but there is a substituent. Then how you can name this particular compounds? You can name this way. So look here, oxirane is the name of this compound. Oxa plus oxygen. OXA, oxa is for the prefix of oxygen. Irene, since it is a saturated one, ANE is there. And then it is unsaturated, E is coming, oxirine. Oxa is same. Azirine, double bond is there, that is the reason azirine. And there is no double bond, so aziridine. So you just look into the difference. Azirine, double bond, and aziridine, no double bond. And this is a substituent, 2-phenyl, one position for the, always when you are numbering, the first number takes the heterocyclic hetero atom. So 1, 2, 2 position substituent is there, 2-phenyl. So 1 position aza group is there. Irene, this is the suffix. Irene is the suffix, aza is the prefix. And oxetane, it's a 4-membered ring with oxygen, is called oxetane. So this will be the substituent. So here what you can do, instead of writing 3-phenyl, you have to write 3-oxo. 3-oxo-oxetane. So if you want to write phenyl means you have to convert this keto into phenyl. So but you take it, you convert this 3-phenyl as 3-oxo, OXO, oxo. Oxo is the substituent for carbonyl compound. So oxetane. And this is, so here the second position is methyl group is there. But here phenyl is there. You have to change this phenyl to methyl. Otherwise, you can change this methyl group into phenyl. Then you can say that 2-methyl azole. Aza stands for nitrogen. OLE stands for 5-membered ring with double bond, unsaturation. So these are few examples of heterocyclic compounds with the IUPAC nomenclature. So with this, I will go to the next kind of IUPAC nomenclature. So look here. So here what you can observe, it's a unsaturated Unsaturated, 3 double bonds are there. Here it's a saturated, 2 double bonds are, 2 oxygens are there. So 2 oxygens means dioxa, a 6-membered ring. Okay, 6-membered ring, what is the suffix? Uh, Here 6-membered ring, what is the suffix? INE is the suffix. And 3 nitrogens are there. Triazine is the IUPAC nomenclature. Dioxyrane, okay, because it is a saturated one, RAN. And this is a 3 nitrogen and it is a 5-membered ring. So 5-membered ring means the suffix is OLE. And 3 nitrogen is there, triazole is the name of this compound. 2 nitrogen is there, diazole, okay, is the name of this compound. Okay, this is about IUPAC nomenclature. Suppose a heterocyclic compound containing 2 or more identical heteroatoms. So this is names 1, 3, 1 position, 2 position, 3 position, and 5th position. 1, 3, 5, triazine. 1, 4, dioxazine. So here dioxane. So here the name is dioxane, ANE. So ZI is not there. Okay, you can remove the ZI in this structure. ZI is not there. So name of this compound is called dioxane. XANE. ZI is not there. Remove the ZI. And this one is 1, 2, 3. Triazole is the name of this compound. 1, 2, diazole. 1, 2, diazole is the name of this compound. So with this, I will go to the next slide. So next is about what is called as, suppose a different heteroatoms are there, then you have to follow this order. Oxygen takes the first priority compared to the sulfur. Sulfur is takes priority compared to the nitrogen. It's because of the more number of heterocycles are present on the oxygen. So that is the thing you need to remember. So look here, in this case, so this CH3 is a substituent. This takes the first priority, 1, 2, 3, 4. So 4-methyl, 1, 3, thiazole is the name of this compound. So 4-methyl is the 4th position, 4-methyl, 1, 3, thiazole is the name of this compound. And here this same 4-methyl, but oxygen is there, oxazole, 1, 3, oxazole. And this is a 6-membered ring. So the 6-membered ring means it will come with INE is the suffix. And oxygen and nitrogen is there. So position at 1 and 4, 1, 4, oxazine. And these are 7-membered ring. So 7-membered ring means the suffix is epine. Oxygen and nitrogen is there, oxaza. So similarly, oxaza. But substituent is there, methyl. And in this, while numbering, this oxygen takes the priority 1, 2, 3, 4. So while numbering, this takes the 1, 2, 3, 1, 3, oxazole. So with this, I will go to the next slide. I think where certain common names itself is retained in the IUPAC nomenclature. So that I am explaining here. So look here, and so position, if a position, and here while numbering, more particularly in the fused heterocyclic, so while numbering, so need not to be start at the heteroatom. Okay, so that is the thing you need to remember, right? So while numbering, need not to be start with the heteroatom. It can be start with the carbon itself. So that is the, again, it's a rule, IUPAC nomenclature. As per that, so this 3-methyl takes a priority. 3-methyl and isoquinoline. So if the nitrogen is at the second position, then it's called isoquinoline. If the nitrogen is at the first position, it's called quinoline. Okay, that is the difference you need to remember. If the nitrogen at the first position, it's quinoline. If the nitrogen is at the second position, it's called isoquinoline. So with this, I will go to the next slide. Next slide also, I will explain about few heterocycles and their IUPAC nomenclature. So look here. So here numbering. So this takes 1, 2. Why? Because a double bond is there. That is the reason. 1, 2, 3, 4. And here I am mentioning the fourth position is H, partially saturated. That is the reason 4H. Okay, partially saturated carbon atoms are shown as a H. H means hydrogen is present on that position. Oxet. So oxa is the prefix, Et is the suffix for this 4-membered ring, because it comes under no nitrogen unsaturated compound. So this is uh, nitrogen containing unsaturated compound but partially saturated. This carbon H is. So 1 and 2 position dihydro. 2 methyl. The second position is methyl. Azet. Aza is for nitrogen. Et is for a 4-membered ring containing compound. And then what is called as a 6-membered ring. And here 2 sulfurs are there, 1 nitrogen is there. So you are numbering, you have to start in such a way that it should be in a continuous 1, 2, 3, 4, 5, 6, 6-membered. So 1 position and the 5th position are the sulfur. And what is that? 2nd position and the 6th position. Okay, is a partially saturated one. So that is the reason 2, 6 dihydro, 1, 5 dithia, and then second position oxygen, nitrogen is there, azaine. INE is for the 6-membered ring. This is about the IUPAC nomenclature of this moiety. And this one, so 2 nitrogens are there, and this should be a substituent only. Since there is a 6-membered ring, I think you know that this is a keto form. This can be exists in the enol form. So when it is comes to the enol form, means bond pair is going over here. This picks up a proton. So that means 2 hydroxy 1, 3 diazine is the name of this particular compound. So 2 hydroxy 1, 3 diazine is the name of this compound. Right. 1, 3 diazine 2-O you can write. That also correct name. 1, 3 diazine 2-O. Okay, you can write this particular one. And this one, it's a saturated one. Oxygen and sulfur is there. This is 1, this is 2. And here 1, 2, 3. 1 means here these 3 carbon atoms are not saturated. So So 1, 2, 3, the saturated carbon atoms. So 3, 4, 5. H I am written. H means saturated. Oxathylane. Oxa means this oxygen. Thia means sulfur. Oleane is the suffix for 5-membered ring. So this is about dithiol. Okay, means 2 sulfur is there, dithia, a 5-membered ring, OLE, and the third position saturated 3H. And here 7th position is H is H is means what is called as uh, partially saturated. This position is saturated. That is the reason H is mentioned. And 7-membered ring, nitrogen. Aza means nitrogen. Epine means suffix for 7-membered ring. This is like that only. So with this, I will go to the next slide. So look here, here the common name itself is retained in the IUPAC nomenclature. Furan, it's a common name, but as per the IUPAC, this is also a furan. Indole, common name as well as IUPAC name. Pyridine, common name as well as IUPAC name. Coumarin, IUPAC name as well as common name. Okay. So with this, maybe what I will do, I will go for a nomenclature in fused heterocyclic. So there are questions, okay, more particularly write a note on IUPAC nomenclature of fused heterocyclic compounds. So in this case, what you need to do, so if this is the compound is given means you have to split like this. After splitting, you have to give a numbering. After giving number, you have to mention the side. So which side the benzene is fused. And one more thing, from these two, you have to select one is a parent ring, another one is fused ring. So usually heteroatom containing compounds are parent rings. Okay. Now this benzene is a fused ring. So what you can do, 1, 2, 3. So position 2 and 3 is fused with the benzene. So first here this will be the substituent, this will be the parent. So for substituent you have to mention benzo. So position where the benzo is fused, B position. So B position is fused. And then pyridine. Okay. Uh, right. Okay. So B position is fused. So that is the reason it's called benzo B pyridine. Otherwise, what you can also write benzo 2, 3 B pyridine. That's also correct. This is the nomenclature for fused heterocyclic compound. In this case, so this moiety is called quinoline and this is a benzofuse. This is a benzene, this is a quinoline. And numbering 1, 2, 3, 4, 5, 6. So here 5 is not given, that you have to remember. So for the side 1 and 2, A. For the side 2 and 3, it's B. Like that, it is coming F4 here. So this position is fused. So this fused one is a substituent, benzo, F position. Otherwise, you can also mention 5, 6, F. All the three you can mention. And this moiety is quinoline. You can write quinoline. So this is how you can give the nomenclature for the fused heterocyclic compound. Okay. So with this, I will go to the next slide. So I will explain about how, suppose if there is a 2 or more heteroatoms are fused. So that examples I am taking. So look here, oxygen ring and sulfur ring is fused. So in such cases, so oxygen containing compounds are more number is there. So you have to give a preference to the oxygen one as the parent compound. This will be the fused compound. And the numbering, so this side is fused. So that is the reason you have to come this way, 1, 2, 3. And this side is fused. That is the reason 1 dash, 2 dash, 3 dash. Okay. So 2 dash, 3 dash B, 2, 3 is also a position for this. So what you can write? So this fused one you have to write thieno. Thieno is the substituent of thiophene. Thieno 2 comma 3 this position 2 comma 3. Otherwise you can also write 2 dash 3 dash. Okay, that's also fine. B position. So B is furan is the name of this compound. So this way you can suppose if two nitrogens are if more number of heteroatoms are there, if it is a same heteroatom, then if the two number of heteroatoms, if those are different heteroatoms, in such cases, more number of different heteroatom containing moiety takes the parent compound, and the remaining will be the fused one. Okay, this is about what is called as fused heterocyclic uh, uh, fused heterocyclic nomenclature. Okay, so in this case, uh, so this moiety is called pyrazine. So when you are writing as a pyrazo, so it is a pyrazo as a substitute. Why 1H? Because it's a saturated one. 1H pyrazo. 4 comma 5 position. This position is 4 comma 5 position. D. So numbering A, B, C, D. D is the oxazole. So this oxygen and nitrogen containing one is called oxazole. So this is how you can nomenclature for a heterocyclic compound. More particularly, two or more number of heterocycles are present in a heterocyclic compound. Okay. So maybe up to this, it's about the what is called as nomenclature. Okay, IUPAC nomenclature, prefix, suffix, examples, and nomenclature for fused compounds, nomenclature for more number of heteroatom fused heterocycles. Okay, maybe in the next class I will discuss about the synthesis and the reactions of azoles. Okay, maybe what you can do, you follow in such a way that you have to be right. Okay,
Thank you, sir.
it's all right.